Okay, today we're going to do another question on physics again. Question 9. We will not go on to question 9A, Roman 1 and Roman 2. I'm stressed on Roman B because I had a hard time doing it like 2-3 days to finally answer it. So now that I've answered it, let's cure you guys by answering it so that you don't have to like search the internet and discover that it does not exist on the internet. So the question B says a toy car driven by, let's read it together. A toy car driven by an electric motor runs steadily on a level ground at 0.5 meters per second and takes a current of 1 ampere, 1.00 ampere from a 12.00 volt. So this is a car which is moving. An electric car is basically an electric toy car which is having a battery inside its core which generates a voltage of 12.00 volts, and now it's running at a steady on a level ground at a steady speed of 0.50 meters per second while sucking in 1.00 ampere of current. So this is the current that it uses when it is moving at this speed. Now when it runs into an obstruction and the wheels stop, the current taken is 3.00 ampere. So this is very important to stress on. Remember, when it runs into an obstruction, it means that and the wheels stop. They have stressed on this part to tell you that the toy car is no more moving, which means the velocity, which was initially at 0.50 meters per second, is now 0. The wheel stops, but current is stopped, and the current now is 3.00 ampere. We will use this information delicately. So what current will be taken when it runs uphill at 0.4 meters per second? Alright, so we'll have to put our data. Question 9b, very important question. We know that the speed when it was having a current of 0.01 of 1 ampere, the speed when it was moving at 1 ampere. How will we represent this? Let's say the speed when it's 1.00 ampere is 0.5 meters per second, and the speed when it sucks in this amount of ampere, that's 3.0 ampere, is 0 meters per second. So when current was at 1.00 ampere, this was the speed, and when it wasn't moving at all, this is the current it sucked. So if you remember from physics classes, we know that power is equals to current times voltage, right? I don't really know if I should be explaining this. For more details, I don't know, comment down below if you have more details on this. But power is generally current times voltage, and we know that power is equals to force times distance. Force times distance all over time. Okay, force times distance all over time. And for distance all over time itself, the rate of change of displacement is equals to the velocity. So I represent it in a vector format, which is equals to current times voltage. So this V, which I represent in vector format, is the velocity, and this V, capital V, is the voltage. So this means that making it into an equation, velocity is equals to capital V, which is voltage, all over force I, and we get ourselves a nice equation which is a relationship between velocity and current, which is Ki, where of course K is equals to capital V, voltage, all over force. So this will be very useful. Why? Because we use this to look for K, and with K we can now get the velocity when the current changes. Remember, we have 3 points. We have a point where the toy car was moving at 0.5 meters per second, and we're using a current of 1 ampere. At the point where the wheel stopped at this 0 meters per second as velocity, and the current is now 3 ampere. And now we have a point where the current is 0.4 meters per second, but we don't know the speeds.